Welcome to Maths Guru Educational Services. If you are joining us the first time on Maths Guru channel, kindly click on the subscribe button so you'll be informed anytime our new video is uploaded on this platform. We also appreciate if you share our videos on other platforms so other people can benefit from the services. Today we are going to talk about some past questions. Precisely, we're going to discuss July-August examination question, that is 2018, and we're going to discuss the first part. Enumerate 3 types of errors in measurements, and what is a variable? Give 2 examples. Differentiate between cluster and purposive sampling techniques. Given this course, we are required to calculate the range, the mode, the mean, the standard deviation of the scores. Then we have a list 4 laws that you would observe to reduce sampling errors when carrying out a research. Then sketch a graph to show each of the following relationships: positive linear correlation, negative linear correlation, no correlation. Very simple. Let's quickly move questions on. We have okay, the first question is to enumerate 3 types of error in measurement. In our study, the course materials, we are given the sources of errors. In there we have that error in measurements can arise due to inaccuracy in the measurement instrument, changing circumstance of what is measured, and then limitation in human judgment. From here we can bring out some of the types of errors in measurement. 1, we have the personal errors. The personal errors are the result of ignorance, carelessness, prejudices, or physical limitations on the experimenter. So these are personal errors, and we can see limitations in human judgment as a source of error. So we have this as one of the types of errors in measurements. Number 2, instrumental errors. This we took from here. Inaccuracy in the measurement instruments. The instrumental errors are attributed to imperfection in the tools with which the analyst works. The imperfection in the tools with which the analyst work. Then the third one here is method errors. This type of error many times results when you do not consider how to control an experiment. For any experiment, ideally you should have only one manipulated variable. The manipulated variable is also the independent variable. So if you want to give additional error, you can have the random error. The random error or chance error, as the case may be, are the combination of results both higher and lower than the desired measurements. Errors that arise when the result is either higher than the desired measurement or when the result is lower than the desired measurement. We call this type of error a random error or chance error. All right, let's talk about the second question there. What is a variable? And then we are to give two examples. A variable is any characteristic or property of an object, event, or phenomenon that can take on different set of values. It can take on different set of values or different qualities. Take note of that. It can be seen as anything to which numerical figures or qualitative description can be ascribed. I take that again. A variable is any characteristics or property of an object, event, or phenomenon that can take on different set of values or qualities. So it can also be defined as anything to which numerical figures or qualitative description can be ascribed. Examples of variables include age. We can say height, weight, temperature, distance, and so on. All these are variables because they can take on a different set of values. The next question is to differentiate between cluster and purposive sampling. Purposive sampling is a non-probability sampling, while a cluster sampling is a probability sampling. That is the first significant difference we can see between the cluster and purposive sampling. Again, I take that purposive sampling is a non-probability sampling, while cluster sampling is a probability sampling technique. So we can take a look at what we have here. Purposive sampling is a non-probability sampling technique where the researcher relies on their discretion to choose variables from the sample population. Here, the entire sampling process depends on the researcher's judgment and knowledge of the context. It is also called subjective sampling. If done right, purposive sampling helps the researcher filter out irrelevant responses that do not fit into the context of the study. On the other hand, cluster sampling is a type of probability sampling. This means that cluster sampling, when used, gives every unit or person in the population an equal and known chance of being selected in the sample group. So in cluster sampling, researchers divide a population into smaller groups known as clusters. They then randomly select among these clusters to form a sample. So the group in which the data are divided into, we have as the cluster, and the act of selecting from these clusters or randomly selecting from these clusters is what is known as sampling. So we call this method of sampling or technique of sampling a cluster sampling. All right, let's check the next question. The TMA1 scores of 20 non-students in Edu 821 as follows. We have them here. We are to calculate the range. All right, we have done this before, but let's quickly run through them to see how we can calculate each of these items given here. The first thing is range. We know that a range is the difference between the highest score and the lowest score. So the range here is going to be, need to decrease. All right, the range is going to be equal to, the highest score here is 8, and the lowest score here is 3. So the range is equal to 8 minus 3, which is equal to 5. The second stuff there is the mode. The mode. How do we calculate the mode here? The mode is simply the score that appears the most. So we are going to look at all these scores to see the one that appears the most. 3 appears 1, 2, only 2 times. 5 appears 1, 2, 3, 4. 4 appears 1, 2, 3. Okay, we may as well form a table for this to avoid confusion. So we have a score here, the frequency, right? So we have 3, 4, 5, 6, 7, 8. All right, for 3 we have 1. Let me use another pen. 1, okay, and 2. So 3 appears 2 times. Then 4 appears 1, 2, and then 4 again, 3. Okay, it appears 3 times. Then 5 now. 1, 2, 3, 4. So we have 4 times. Then 6. 1, 2, 3, 4, and 5. It appears 5 times. 7. 1, 2, 3, 4. 4 times. And then 8 appears only 2 times. So we have 2 times. So we have to check to see that it corresponds with the total number of students. We have 2 plus this will give us 6. 6 plus 5, 11. 11 plus 4, that is 15. 15 plus 3, 18, plus this 20. So we have summation F to be equal to 20. All right. So the mode here is simply equal to the number that appears most, or the scores that appear most, which is equal to 6. So we have it as 6. Then remember, it is not the frequency we are writing down as the mode. It is the score itself. So the score is 6. The frequency of this score is 5. So it appears more than every other score that we have there. Then the next question is to calculate the mean. To calculate the mean. All right, to do this, we have to multiply the score and the frequency here, fx. We have to find our fx. 3 times 2 will give us 6. 4 times 3 will give us 12. 5 times 4 will give us 20. 6 times 5 will give us 30. 7 times 4 will give us 28. 8 times 2 will give us 16. We are going to add what we have here now. Summation fx is equal to 112. Therefore, the mean is equal to summation fx over summation f, and that is equal to 112, which is the summation fx here, and summation f is equal to 20, so we put it there. So when we divide 112 by 20, you're going to have 5.6. So the mean is equal to 5.6. Now, the next target is to calculate the standard deviation of the score. Let's quickly do that. So we need to have the deviation of the mean from the score. That is the score minus the mean. That is the deviation of the mean. It's called the deviation of the mean from the score. So the first, we're going to have 3 minus 5.6. 3 minus 5.6, and we're going to have negative 2.6. 4 minus 5.6. We're going to do that throughout. 4 minus 5.6, we are going to have negative 1.6. Then we have 5 minus the mean, which is 5.6 there, we're going to have negative 0.6. 6 minus 5.6, we're going to have 0.4. 7 minus 5.6, we're going to have 1.4. And 8 minus 5.6 is 2.4. So the next is to square this. X minus x bar square. So we're going to square the deviation now. The deviation of the mean from the score. So negative 2.6 square. All right, we have negative 2.6 squared will give us 6.76. Negative 1.6 squared will give us 2.56. Negative 0.6 squared will give us 0.36. 0.4 squared will give us 0.16. 1.4 squared will give us 1.96, and then 2.4 squared will give us 5.76. And since we have all these as a recurring data, we still need to multiply the frequency by the square of this deviation. So maybe writing the formula down will help us to remember all this. Okay, let's quickly have a formula written down. We have standard deviation, which is the square root of variance, square root of summation f into x minus x bar squared over summation f. All right, it means we still need one more column here. Let's quickly construct that. All right, what we just did here is to rearrange the table and include columns to contain what we are supposed to do here. So the next thing we are going to do is to find our f of x minus x bar square. So we are going to multiply the frequency by the squared of the deviation of the mean from the score. So we are going to have 2 multiplied by 6.76. This is equal to 13.52. Then we have 3 times 2.56. So when we multiply the frequency by this column, we are going to have this as a result. So the next thing is to sum everything here. Summation of x minus x bar square, and this will give us 42.8. You can sum it to be sure that that is correct. 0.8. Do the summation again. So the standard deviation is equal to the square root of summation f into x minus s bar square is equal to 42.8 divided by summation f is here given as 20. So when we divide this, we're going to have the root of 42.8 divided by 20, and this will give us 2.14. The next is to find the square root of 2.14, and this will give 1.46, approximately 1.5, which is approximately 1.5 as the standard deviation of the distribution we have here. The next question is, list 4 laws that you would observe to reduce sampling errors when carrying out a research. These are the laws you have to observe. Increment, it has to do with increasing the sample size. Number 2, stratification, that is, you have to divide the population into groups. Identity, it is concerned with knowledge of the population. Then the fourth one is randomization, which is the random selection to eliminate bias. I believe this is straightforward. Increment, it has to do with increasing the sample size. You can simply say increasing the sample size. 2, dividing the population into groups. 3, knowledge of the population, and 4, random selection to eliminate bias. Question number, C section. We are required to sketch a graph to show each of the following. Right, we need to note that for a given distribution to be a set of scores to be positive linear correlated, the increase in one must be corresponding to the increase in the other. So the increase in the variable s, if the increase in the variable s brings about the increase in the variable y, then we say they are positively correlated. And if the increase in the set of data under s, for instance, we have 2, and in y we have 5, when we have x to be, let's say, 3 now, this decreases to, let's say, 2, and if we have x to be equal to 5, then y decreasing to 1. I'm just giving an instance here. For something like this, we said that they are negatively correlated because the increase, we have the increase in the variables, the scores under x, and the corresponding score under y is decreasing. When we have x increasing, y will be decreasing. So they are negatively correlated. So take note of that. So we are going to draw a scattergram to show positive linear correlation, negative linear correlation, and no correlation at all. Let's quickly have a graph. We have the ordinates, which is the y-axis, then the abscissa, this is the y-axis, the x-axis. So for us to have a positive linear correlation, we should have something of this nature. They should be aligned such that we have increase in y bringing about a corresponding increase in x, or increase in x corresponds to increase in y. So we'll have dots aligned this way. If they are aligned this way, we say they are positively correlated. So we have a positive linear correlation. Again, if the scattergram is this way, we have abscissa, the s coordinate, and we have the y coordinate, which is the ordinate. If we have let's say we have something this way, you can see that, let's assume we have all these dots corresponding to points on the y-axis, and we can locate each of them. So you can see that if this is 1, 2, 3, 4, 5, 6, 7, and we have here 1, 2, 3, 4, 5, 6, 7. Okay, let's have 5, 6, 7. Okay, we can see that we have 1 here. When we have 1, x equal to 1, our y is equal to 7. When y is equal to 6, our s becomes 2. You can see that y is decreasing, yx is increasing. Maybe I should use like 3-4 points to make everything so clear here. To discuss, you can have as many points as you like if you're going to draw your own graph. So we have the ordinates, we have the abscissa. So y, x. Okay, let's simply have 4 points. One, 2, 3, 4. 1, 2, 3, 4. Okay, so if we have a graph like this, and we have when y is equal to 4, s equal to 1. Let's give it this way. When y is equal to 3, x is equal to 2. So we have it this way. When y is equal to 2, x is equal to 3. When y is equal to 1, x is equal to 4. So if we have something like this, you can see that it is sloping this way down. Can you see? So for a graph like this, we say that we have a negative linear correlation, because the increase, the decrease in y brings about we have a corresponding increase in the value of x. So when we have y to be equal to 4, our x is equal to 1. When we have y decrease to 3, our x increased to 2. When y decreased to 2, our x increased to 3, and so on. So you can have as many points as possible on the graph, but let it be shown that when one is increasing, the other one is decreasing. So we have the graph sloping from right to left, downwards. But for this one, which is positive linear correlation, we have if the points are shown this way, you see that when this one increases, the y-axis score also increases. So take note of that. Then the last one is no correlation at all. When there is no correlation, we're going to have something like this. We have the s coordinates, the y coordinates, okay? If there is no correlation at all, then the graph will be like clustered this way. It will just be you have a clustered graph this way, so no direction. It will be without direction. So for this we have no correlation. For this, since we have it sloping from left up to the right, we have positive linear correlation. And for this, we have negative linear correlation. So this is about sketching a graph to show the relationship between two set of data. Please don't forget to subscribe to our channel. Share our video as well for others to benefit. So we will come back to you again as long as we have questions and responses from you. Thank you, and God bless you.